Okay, today we're going to talk about how would you make a logical circuit that can do addition of binary numbers. I assume that being computer science majors, you guys probably are very familiar with binary numbers, but just to be on the safe side, let's review it quickly. Okay, so binary numbers means numbers that are written as sums of powers of 2 as opposed to sums of powers of 10 as we usually do. Let's just do an example. Let's take the number 5,378 written in base 10, which means decimal system, the one that we're used to. So I'll put a little 10 down here to represent that. Okay, so what is that really? That is 5 thousands plus 3 hundreds plus 7 tens plus 8 ones. Now, on the other hand, if I wanted to write that number as a sum of powers of 2 instead of a sum of powers of 10, then the way I would do that is this. I would write it as, well, let me just point out that 5,378 is equal to 4,096 plus 1,024 plus 256 plus 2. And this is 2 to the 12th. This is 2 to the 10th. This is 2 to the 8th. And this is 2 to the first power. So how I would write that is I would write 1 times 2 to the 12th plus 0 times 2 to the 11th plus 1 times 2 to the 10th plus 0 times 2 to the 9th plus 1 times 2 to the 8th plus 0 times 2 to the 7th plus 0 times 2 to the 6th plus 0 times 2 to the 5th plus 0 times 2 to the 4th plus 0 times 2 to the 3rd plus 0 times 2 squared plus 1 times 2 to the power 1 plus 0 times 2 to the power 0. So now I have them written as, I have that number written as sums of powers of 2. Now, just like when I did it in powers of 10, you see these are called the places, right? You have the zeros place, or, sorry, let me say that again. This is the ones place because 10 to the 0 is 1. And then the tens place, the hundreds place, the thousands place. Those are places. And these numbers are called digits. Correct? Okay, so now when we want to write it in powers of 2, then here, look at what we have. We have the digit 0 in the ones place. The digit 1 in the twos place. The digit 0, sorry, there we go, the digit 0 in the fours place. And then 0 in the eights place. And 0 in the 16s place. 0 in the 32s place. 0 in the 64s place. 0 in the 128s place. And then 1 in the 256s place. And 0 in the 512s place. and 1 in the 1024's place. 0 in the 2048's place. And finally 1 in the 4096's place. Okay, let me put a little 2 here to tell you that that's in base 2. So these numbers are the same number. This is the number 5378, written in base 2. This is the number 5378 written in base 10. Base 10 we call decimal. Base 2 we call binary. Okay? The trick is to start big. So what I did for that was I just started looking at powers of 2, and I wanted to find the largest power of 2 that can be taken out of 5378. And I found that to be 4096. If I go to the next power of 2, it would have been 9192, I think, which would have been too big, you see. 4096 is the largest power of 2 that can be taken out of 5378. So I started from there, and I subtracted 4096 from 5378. I found out what's left over. And then from there you find the largest power of 2 that can be subtracted from that, and you just continue on. Notice that when your base is 10, the digits are allowed to be anything from 0 to 9. And when the base is 2, the digits are allowed to be anything from 0 to 1. Okay? Let's review addition and subtraction in binary numbers. It actually works the same as it does in the decimal system, with carrying over when you're adding and borrowing when you're subtracting. It's just that in the base 10 system you carry over or borrow tens, and in the binary system you carry over or borrow 2's. Okay, so let's do this. Let's do 427 plus 581. Let's add those together. Okay, this is like first grade stuff, right? So we get an 8 here, and here in the next spot we get a 10, right? So what do? So we write a 0 here, and we carry the 1 over to here. Okay? And then let's add those together. What is that? 9 plus 1 is 10. So we write a 0 here, and we carry a 1 over to the next spot, and then we have 1008. Okay? All right. Now, let's do, these are in base 10, by the way. Okay, so now let's add this number. Let's not even worry about what this number is. Let's just say there's a base 2 number. And let's add another base 2 number. Okay, so 1 plus 1 equals what? It equals 2. Now, in the binary system, 2 looks like this. That's 2. In the binary system, it is 1 times 2 to the 1 plus 0 times 2 to the 0. Okay? So, I add 1 plus 1 and I get 10. How do I write that? I'm sorry, that's not right. I add 1 plus 1 and I get 2. How do I write that? With a 0 here, and then I carry the 1. Okay? And then in the next column, I have 1 plus 0, which is 1, which requires no carrying over. And then in the next column, I have 1 plus 0, which is 1. And then in the next column, I have 1 plus 1, which is 2. So I put the 0 here and carry the 1 over. And now I have 1 plus 0 plus 1, which is 2. So I write a 0 here, carry the 1 over. Now I have 1 plus 1 plus 0, which is 2. So I write a 0 here and carry the 1 over, and there's our answer. Okay? Let's do subtraction. All right, let's practice in base 10. Let's do 3,298 minus 1,400 and how about we'll do 79. Okay, so how does this work? Well, in the first column, I can't take 9 away from 8. So what do? We borrow from the next column over, right? And we cross that out, cross that 9 out, and we replace it with a, what? An 8. And we carry the 1, or we borrow the 1, right? Now I have 18 minus 9, which is 9. And in the next column, I have 8 minus 7, which is 1. And in the next column, I have 2 minus 4, so I have to borrow. I take 1 away from the 3, and it gets knocked down to a 2. And I borrow that 1, and I put it there. Now I have 12 minus 4, which is 8. And I have 2 minus 1, which is 1. Okay, that's easy to do. Okay, in binary, let's practice it. We use the same two numbers we did before, okay? We'll do 1, 0, 1, 1, 0, 1 minus, I'm not sure why I even wrote that 0 there. You normally would not do that. Okay, we're going to subtract 1, 1, 0, 0, 1. Okay, so first column, 1 minus 1, that's 0. Second column, 0 minus 0, that's 0. Next column, 1 minus 0, that's 1. Next column, 1 minus 1 is 0. Fifth column, 0 minus 1 I can't do, so I have to borrow. So we drop that one down to a 0, and I borrow the 1 and take it there. Okay, now you just have to be really careful here. That now says 1, 0 minus 1, right? Let me write that down. That says this, 1, 0 minus 1. But what's this number right there? That's not 10, is it? That's the number 2. Remember, look, it's written up here. That's the number 2. So 1, 0 minus 1 equals 2 minus 1, which is 1. That's what should go down here. And there's our answer. Okay, that's how binary addition and subtraction works. Let's not worry about multiplication and division, okay? Because the goal here is I want to show you how to write a logical circuit that will do binary addition. And this isn't simple. This is going to take some steps, okay? First, we need to start with a circuit that will add two one-digit binary numbers. Okay, this is on page 82, if you need a different explanation than the one I give. Okay? Here's what we're going to do. let's call the two numbers P and Q. Okay, that's what you call numbers that you add together are called summands. Okay, so P and Q are both 0 or 1, right? Let's make a table for this. P and Q. Okay, we might have P be 1 and Q be 1. We might have P be 1 and Q be 0. We might have P be 0 and Q be 1. Or they might both be 0. Okay? Let's write their sum over here next to that. So, what's 1 plus 1 in binary? It's 2. And how do I write 2 in binary? I write it like this. What's 1 plus 0? It's 1. Which would just be written that way, but I want everything to be written with 2 digits here so that things will be consistent. So normally if you add 1 plus 0, you would just write 1. I'm going to write 0, 1, okay? 0 plus 1 is also 1, and 0 plus 0 is 0. Okay, so these are our summands. And this is our sum. Now, I want to split that sum, which is a 2-digit number, into 2 separate columns. Now, I'm going to erase where it says summands and sum because for a reason that I don't know why they chose this, but just to be consistent, I'm going to stick with the book. And the book calls the ones digit of the answer, calls that the sum, even though the sum is really the whole answer, okay? And the twos digit, the book calls the carry. Okay, so we will refer to those as C and S. And either way, we have P plus Q equals CS. Okay? All right. Now, if you look at those, let's look at P, Q, and the carry. And you might recognize that this is exactly what an input-output table looks like. For an AND gate. Do you recognize that? If I replaced the word carry with P and Q, then that would fit perfectly, wouldn't it? So in other words, to calculate the carry, you run the two summands, P and Q, through an AND gate. Whoops, the AND gate doesn't have a curved back, it has a straight back. So you run P and Q through an AND gate, and that tells you your carry. All right? Which is the second digit of your answer. Second if you're going from right to left. Okay, now, how do you calculate the sum? So for that, let me erase that box. So for that, let's just look at this column and this column. and the sum column. This one's not as obvious, so I'm going to point it out to you because it's not something I would expect you to guess right away. Let me write it down and then we'll look at it and see if we agree. So that is P or Q and not P and Q. So in other words, if I wanted to say that in words, I would say P or Q, comma, but not both. Let's see if you agree with that. So in the first row, I've got both. So that is turned off. In the second row, I've got P, and so that's turned on. In the third row, we have Q, so that's turned on. And in the fourth row, we have neither one, so it's turned off. So the only two rows where we get a signal output is where we have P or Q, but not both. Okay, and that's what this says over here. It says P or Q and not P and Q. So that's P or Q, but not both. So that's how you get the sum, which, again, weird name for it, I think, but that's what the book calls the ones digit of our answer. It calls it the sum. Okay, so that's how you get the ones digit. You run P and Q through some gates that will produce that. Okay? P or Q and not P and Q. So let's do that. So we'll take P and we'll take Q. And let's branch off of those two. And we'll go through an OR gate. That'll give us P or Q. And what comes out of that is P or Q. Now I want to do that and not P and Q. Well, I already have P and Q right here. So if I branch off of there, okay, send that output through a NOT gate. Now what would be coming out of there is not, whoops, I should have put a parenthesis. That will be not P and Q. And what's coming out of this OR gate here is P or Q. And if I put those two through an AND gate, then what comes out of there will be P or Q and not P and Q. That's exactly the number we're looking for this column. So there you go. That is a logical circuit that will add two single-digit binary numbers. You plug in the two numbers, P and Q, which are both either 0 or 1. I said a single-digit binary number, so they're either 0 or 1. And you get this answer here, 2 digits, a 2-digit answer. CS, where C is 0 or 1, S is 0 or 1. Okay, we can test that. Let's do that. Let me just put some numbers there, okay? So let's say you want to add 1 plus 1. Okay, we already know the answer, but let's write the answer down over here. 1 plus 1 equals 2. And how do you write 2 in binary? You write it like that. So 1 plus 1 should equal 1, 0. Okay, so let's go ahead and do that. Okay, so 1 and 1, that means in the logical circuit that there is a signal going through those wires, right? What would come out of the AND gate? A signal or no signal? Well, if two signals go into the AND gate, then a signal should come out, shouldn't it? So that's a 1 coming out, and so we'll get a 1 right there. Okay? And when that 1 goes through that NOT gate, what's going to come out of that is a 0, right? Now, also, I have these two 1s branching off and going through here, through an OR gate. What comes out of an OR gate if two 1s go in? A 1 comes out, right? So at this AND gate over here, I've got a 0 and a 1 going in. In other words, one wire has a signal coming through it and the other wire does not. Will there be a signal coming out of the AND gate or not? How do AND gates work? If only one signal is going in, then nothing comes out. So we get a 0 coming out. And here's our answer. 1, 0. You see how that works? Now, we're going to call this whole circuit by a name so that we don't have to recopy it every time. Let me erase these extra markings here. So P and Q are the numbers we added together, and what came out was the digit C, the book calls the carry, and the digit S that the book calls the sum. Okay, we're going to call that whole thing a half adder circuit. Okay, and that is for adding two single-digit binary numbers. All right, let's go ahead now and take the next step. Okay, now we're going to make a circuit that will add 3 single-digit binary numbers. And the reason why you have to be able to add 3 is because when you add 2 binary numbers together that have more than one digit, you will oftentimes end up having to add 3 numbers together because of the carryover. We saw that up here. Let's scroll back up. Look, for instance, at this column right here. No, never mind, that was a subtraction problem. Let's look over here. You see, I'm only adding 2 numbers together, 101101 plus 11001. But in the first column, the 1 plus the 1 equaled 10. And so that 1 from 10 got carried over to the next column. So even though it's an addition problem of 2 numbers, in the second column, I'm having to add 3 numbers together. So if we want to construct a circuit that will add any 2 numbers together in binary, then that circuit will have to be able to add 3 single-digit numbers together. And that's what we're going to do now. So suppose we have P, Q, and R that are single-digit binary numbers. So they are each either 1 or 0. And we want to add them together. We will get an answer that is either 1 digit or 2. We will write it as 2, although the first one might be a 0. And we'll go ahead and call that C and S again, just like in the previous problem. Okay? Now, how do you do that? Even in base 10, how do you add 3 numbers together? You first add 2 of them, and then you add the third one to the answer, right? So here's how we would do this. In reality, we would do P plus Q, and let's call the answer C1S1. We already have a circuit that will accomplish that. The half adder circuit will accomplish that. And then we add R to the answer of that. Okay? Now remember, R is just a single digit number. So R only gets added to S1. Now we might have some carryover, okay? But the point is, we would be looking at S1 plus R. And whatever we get here, which you could call S2 if you want, and C2. Okay, but the reality is that this number S2 is going to be this number that we're looking at. And so if you're reading this in the book, you'll see that they don't even put a 2 there. They just call it S, because that is going to end up being S. So let's write down just what we've done so far. We're not done, but let's write down what we've done so far. You have P and Q, which are 2 single-digit binary numbers. And we want to add those together. So that gets us, let me go back to where we were. Okay, that gets us this far. How do we add 2 single-digit binary numbers? Well, I could copy that whole circuit right there. But I don't need to. I've called that circuit the half adder circuit. All I need to do is put a box here. Shoot. All I need to do is put a box here and identify that as a half adder circuit. Okay? So in other words, that circuit right there would occur right there. Okay? And what comes out of that circuit? These 2 digits right here, C1 and S1. See, look up there. What comes out of a half adder circuit? 2 digits come out, a C and an S. So 2 digits come out, a C and an S. Okay? And then what's the next step? What did we have written here before? Then we want to add R to that. So remember what I said? We take this part right here, and we do that addition. So, by the way, I should have put 1s on here. That C and that S that come out of our half adder circuit, that's the first C and S. Okay, now I want to add the single digit S1 to the single digit R. How do I add 2 single digit numbers? With the half adder circuit. I just need to move that S1 out of our way. Let's write it here, and we'll put the C1 there. Okay, so now I put a half, sorry. Now I put a half adder circuit here. To add together the number R with the number S1. Now the book labels the first half adder circuit as half adder number 1 and the second half adder circuit as half adder number 2. Okay, now let's talk about what's going to come out of there. So remember I said we're going to get, okay, I should go ahead and write 2 lines coming out because we know that 2 digits are going to come out. Okay, let's call them C2 and S2. So up here in gray I'm going to write C2 and S2. Okay, but let me remind you, this right here is going to be this number, S, because it's going to be here. It's going to be an S, okay, and then we need to talk about where the C2 is going to go. So my point right now is that we don't have to put that little 2 next to the S because that's actually our final S. There's a typo in the book, and the book is accidentally calling it T. Okay, now what we need to talk about is what to do with this C2, and also, by the way, what to do with this one, the C1. Okay, so let's think about this. Whoops. Let's just do all the different cases. Okay, the C2 would be carried over and would end up there, and I would add the C2 and the C1. So you might be thinking, oh, so we need another half adder circuit. Well, it's not even that complicated. It's actually easier. Let's just do this by cases, okay? If C1 is a 1 and C2 is a 0, then what should go down here? Would be a 1, right? I said if C1 is a 1 and C2 is a 0, then we should get a 1 down there. If C2 is a 1 and C1 is a 0, then we should get a 1 down here. If they're both zeros, then we should get a 0 down here. And finally, if they're both 1s, then in that case, we would have made a mistake. It's not at all obvious why, but let me just show you here. If C1 is a 1, then what does that mean P and Q were? The only way for C1 to be a 1 is if P and Q were both 1. Because then I would get 1, 0 down there. But if S1 is a 0, then whether R is 0 or 1, either way, C2 would be a 0. You have to think about this. It's not obvious, okay? So I'm going to say it again, but you're probably going to have to just think about it, okay? And let me write this stuff down, okay? So C1 and C2 can't both be 0. Sorry, I meant to say they can't both be 1. Because if C1 was a 1, that means that P and Q had to both be 1 to start with. So P plus Q would have equaled 2, which is written this way, which means that S1 would have been 0. So S1 plus R would have no carryover. In other words, C2 would be nothing. Okay, so if C1 is a 1, then C2 has to be 0. So we only have 3 possibilities. And I want to write the 3 possibilities down here. I'll draw a box over here. The 3 possibilities are just this. 0, 1, 1, 0, or 0, 0. Those are the only 3 possibilities for C1 and C2. Okay, and this right here, their sum is going to be our final C. If C1 is 0 and C2 is 1, then their sum will be 1. If C1 is 1 and C2 is 0, the sum will be 1. And if they're both 0, their sum will be 0. What does that look like to you? Doesn't that look like exactly C1 or C2, where we have removed the possibility of them both being 1? So in other words, what I want to do to get my final carryover digit here is I want to take C1 and C2 and run them through an OR gate. And there you go. Now I just want to point out to you, the book has 2 typos here. The book calls this S and this T. I have no idea where they got those letters from. It's clearly just a mistake. Okay, this whole circuit right there is what we're going to call a full adder circuit. And it's a circuit that will add 3 single-digit binary numbers. And remember, each of those boxes that says half adder is really one of those circuits. So this is really fairly complicated. I'm not going to take the time to do it, and you don't need to either, but just imagine that whole setup being right plugged into there, and also another one of those being plugged into here. Okay? All right. One more step. Wait, before we go on, I just want to convince you that this is correct. First of all, let's write down the different possibilities. We're adding P, Q, and R in binary numbers. They might all be 1s. They might have P as a 1, Q as a 1, and R as a 0. Or we might have P and R are 1s and Q is 0. Or P's 1, Q and R are both 0s. And so on and so on, okay? There's 8 possibilities. Let's write down what their sum should be. 1 plus 1 plus 1 is 3. And in binary numbers, 3 looks like this. 1 plus 1 plus 0 is 2, which looks like this. 1 plus 0 plus 1 is also 2. 1 plus 0 plus 0 is 1. 0 plus 1 is 2. 0, 1, and 0 added together is 1. 0, 0, and 1 added together is 1. And 3 zeros added together are 0. So if I call that digit S and this, C, sorry, and this digit S, let me just show you, we don't have to do all of it, it probably takes a long time, but let me just show you how you can check our circuit that we wrote down and see if it's correct, okay? Pick a row. I'll just pick this row. Let's check to see if our circuit would produce that row correctly. So in this case, P is a 1, Q is a 0, and R is a 1. What will come out of this half adder circuit if a 1 and a 0 go in? Let's just look up here. Look right there. If a 1 and 0 go in, then what comes out is the C is a 0 and the S is a 1. So this would be a 0 coming out. This would be a 1 coming out. Now let's look at this half adder circuit. We've got 2 1s going in. What will come out? 2 1s going in. A 1 comes out for the C, and a 0 comes out for the S. So this would be a 1, and this would be a 0. And now look at this OR gate. I've got a 0 and a 1 going in, so what comes out is a 1. So apparently our answer should be 1 0. What is it? 1 0. So that's correct. And you could check every single row that way. Okay, now the last part is actually not quite so bad. Now we can make a circuit that will add any 2 binary numbers together, no matter how big they are. The book is an example where you take a 3-digit binary number, and they call the digits P, Q, and R, and they add another 3-digit binary number, STU, and then you get an answer. Now the answer might have how many digits? A 3-digit number plus a 3-digit number can have up to 4 digits in the answer. The book is going to call them W, X, Y, and Z. Okay, and here's how you do it. Take the 2 1s digits, these guys here. You run them through a half adder circuit. Okay, R and U. Here, let's put it here. R and U. They go through a half adder circuit. I'm just going to put HA. Okay. 2 numbers are going to come out, an S and a C. The S number that comes out is this number. So I'm just going to write it like this. I'm going to write S1. Whoops, that should be black. S1 coming out, but that number ends up being part of our answer, the digit Z. Okay. The other thing that comes out of this is the carryover digit. We'll call that C1. Okay, and what you do is you take that carryover digit along with, let me actually write that C1 on top instead of below. Okay, you take that carryover digit along with these two numbers, Q and T, because that's what you would do, right? The carryover goes up here, right? And you add Q and T plus the carryover. So how many numbers are being added together now? C1 plus Q plus T, that's 3 single-digit numbers. So to add those together, what kind of circuit do you need? You need a full adder. And what's going to come out of the full adder? An S number and a C number. Let's call them S2 and C2. And that S2 number is going to end up being part of our answer. It's going to be the digit Y. The carryover from that goes up here, and we add it to P and S. So C2 and P and S all feed into a full adder circuit. And what's going to come out is an S number and a C number. And those are going to be our digits X and W. Okay? And you can imagine from that how you would write a circuit that would add two 4-digit numbers together, or two 5-digit numbers, or so on and so on. Okay, so I want you to hopefully understand. If that ends up being beyond you, then you might have to resort to the next best thing, which is memorize that circuit right there. Okay? These as well, but those are harder. But I want you to be familiar with a half adder and a full adder circuit and how to put them together to add any size binary numbers together. This one here looks like the biggest, but it's the easiest. Okay? That's it for today.